As a first LEGO League coach for several years, I've looked at a lot of different FLL robot designs. One that really impressed me was the Orka concept robot, and I always wanted to build a smaller, simpler version of it. And so here it is. This robot has 4 different outputs that can be used to connect to powered attachments easily enough. I've got simple drop-on examples of what a powered attachment might look like. And you can see they just fall right on top of those gears, like so. I'll show you a quick example of how this robot selects gears and powers these attachments. They can drop on in a variety of different orientations, and using some simple gearing techniques, we can shift the output to a variety of different directions. Here's an example. Do a simple spin. You can see what's happening here is the robot is using 2 different motors. One motor selects which output is operational using a transmission underneath the hub, and a second motor is used to drive a shaft that powers the output. So it's cycling between all of its different output options here. There goes white and red and blue and then orange, and it keeps going back around. This is the motor that's driving the output. This motor over here is selecting them between the gears. The outputs are a pretty standard configuration for drop-on attachments that use a couple of axles to help keep things aligned, and then the same dog gear on each output. Underneath, you can see there are worm gears that drive a couple of gears to convert or carry the power from the worm gear over to the output gear. The worm gear makes sure that the output doesn't move when the transmission is shifted into neutral. It takes an awful lot of force to move a worm gear, so they won't slip or anything like that when the output is not using that, or when the robot's not using that output. And it also produces a lot of torque on the output. The trade-off, of course, is that the output gears could be slow. So to compensate for that, of course, you can use some gearing exchange on your accessories in order to speed up the accessory that you're trying to power. Underneath the robot, you can see kind of a standard configuration. I've got these wheels driven by the motors on the outside, and then the 2 motors in the middle are the ones that are operating the outputs and the transmission. I use 2 light sensors in pretty common configuration like this to allow for squaring up 2 lines and easy line following on either side of the robot. You'll notice that these 2 caster balls are mounted on shock absorbers. It provides a little bit of suspension for the robot, so when it goes over any kind of rough terrain, it can handle that easily. As you can see, I think I made it almost too small. The wires are kind of difficult to manage. I think it might be smart to actually make this a stud or 2 larger in a couple directions in order to give better routing for the wires. But I really tried to make this as compact as possible. Do one more example. Let's just drop these on here in any orientation. Like that. And you can see by using a standard mounting plate, it gives me an easy way to put attachments on. All of my attachments can follow a standard design pattern and fit onto any output. And you'll see when I run the example program, I do a quick spin. Start. Just to spin the robot around for the heck of it. And there it's driving each of the outputs in sequence. Orange, blue, red. And again, that's top speed for the outputs because I'm going from a worm gear to a regular gear. but if you needed faster outputs, you could use some gearing to speed those up. I do notice that sometimes the gear selector gets stuck as it's trying to slide the drive gear into position. And so you'll notice I spin the output shaft a little bit in order to make sure that if it is stuck, the spinning output shaft will get it unstuck as it changes gears. Let's take a look underneath the hub. I'll see if I can do this here. I'll just go ahead and unplug everything and look under the hub. All right. This is a pretty standard gear selector system. See if I can get a little closer. There's the orange gear here in the middle, or ring, I guess, that pushes these collars into engaging one of the 4 red gears. And then by using these idler gears, it converts the power from whatever red gear is engaged to an output shaft. So there's a row of gears on the bottom, and then these 2 shafts on the top with 4 more gears up here. And then again, this is all designed as compactly as possible. Let's take the accessories out of the way so we can take a closer look. You'll see that, for example, this red gear right here, when it's engaged, drives this gear right here, which is connected on a shaft to this worm gear. And then there's a small idler gear there and another behind it to the shaft that this output gear is connected to. I don't think I could have made it any more compact than I did. As you can see, I'm limited on this direction by these 2 motors like this. I couldn't really come up with a better motor configuration that allowed for me to tighten this up in this axis or this direction. The only thing that you could possibly do would be to stand these motors up vertically or to stack them somehow. And then, of course, the side to side, as long as these 2 motors are here, is limited by the width of this motor, the width of the wheel, and then a little bit of space to connect to the outer wall to provide some stability for those wheels. So I think this is about as compact as I could get it. Really had a hard time getting the suspension in there, but I think it's a nice addition to give you that little bit of bounce over rough terrain. All right, that's it. If you have any questions, drop them in the comments. Good luck, LEGO teams.